Optimization is a process whereby we find the maximum or the minimum value of a quadratic function. This process is done by finding the vertex of the quadratic function. So if f of x equals ax squared plus bx plus c, then the vertex is given by the formula negative b over 2a, comma, f of negative b over 2a. Remember, if a is greater than 0, you have a minimum, and if a is less than 0, you have a maximum. So in this one, a farmer with 2,000 meters of fencing wants to enclose a rectangular plot that borders on a river. If the farmer does not fence in the side along the river, what is the largest area that can be enclosed? And what is the length of each side of the enclosed area? So we got very little information. We know we got 2,000 meters of fencing. It borders on a river. And he is not fencing in the side along the river. So that's all we really need are given. So with questions like this, it's usually easier just to draw a picture. So we got some rectangular plot and it's not fenced along a river, so we have a very nice river here. And so we have some fenced in area, and we know we have 2,000 meters of it. So I look at this and I think, well, these two sides, assuming it's perfectly rectangular, are going to be the same length, and this is some length we don't know. So I can say that this here is some x length, which means by default that this is also some x length. Makes sense to me. But then what do we do about this? Well, I have two x lengths here, and I have 2,000 meters to begin with, so I can say that this, logically, is the amount I start off with, 2,000 meters, minus these two sides, 2x. So this length and this length is just x, whereas this is the amount of fencing I have to begin with minus these two lengths, which makes sense logically. Well, now what do we got to do? We got to find the area, the largest area that could be enclosed. Well, area is equal to length times the width. We know that for a fact. And I can say that this here is the length, and these two are the widths. So I can just plug my W and L in for W and L here. So my area is going to equal L, which is 2,000 minus 2x, times my width, so parentheses, and my width is just x. So this is my area in terms of x. So I could even just rewrite this as a of x. And now I can distribute the x in, and I'm going to get 2,000x minus 2x squared. So I got some function here. Seems okay. My a value is a -2, which means if a is less than 0, my vertex would give me a maximum, and I need the largest, so feeling pretty good that this is correct. So let's find out our vertex. So a and b, a is going to be -2, and b is going to be 2,000. Now I can plug it into my vertex, so x equals -2,000 divided by 2 times -2, which will be double negatives giving you a positive, so 2,000 divided by 4, which will reduce down to 500. Not too bad. Nice even number. Feeling pretty good. And again, this is meters, so 500 meters. So what can I do with this? Well, I need to know what the largest area can be. So if I have 500 and I have a function, a of x, that represents the area, I can just plug 500 in here and find out my area. So a of 500 equals 2000 times 500 minus 2 times 500 squared. And that's going to give me, if you just, again, throw it all in a calculator, 500,000 square meters. Now let's abbreviate it like that. So what is the largest area that can be enclosed? 500,000 square meters. So we know what the area is going to be, but what are the dimensions? What are the lengths? So we know that the width is 500, x, so 500 here and 500 here. So what's the length? Well, I can just plug 500 in here, and I will find out the length. So length is going to be equal to 2000 minus 2 times 500, which means I'm going to get 1,000 meters. So what are my dimensions? Well, my dimensions are going to be, in no particular order, 500 by 1,000 are going to be my dimensions for this enclosed area.